Hello world. By popular demand, I will be doing, sorry, I've not said officially, but many of you have emailed me. I will be doing this year section D skeleton code, but I have a PhD going on. That's a lot of work. But my plan was to start when study leave start, which is like next week. But just to warm up, because one of you by email, and thank you a lot. You reignited my passion for doing this. As asked for section B exercise, and specifically the one from last year. Now, I've got plenty of section Bs. They're nice. They're self-contained, 20 minutes. As long as there's not 3 minutes of the teacher talking as an intro. I rate them, if you will, as programming exercises. So this is about bouncy numbers, which is a made-up thing. But sometimes, if it had been capital B, it might have been Lord Bouncy, the owner of the original Bouncy castle. Write a program that gets the user to enter an integer. It should keep doing this, the program, not the integer. Well, I guess both of them, right? Until they enter a value greater than 0. So we know it's going to be an int, but we're not sure it might be a positive int, strictly positive int. So we don't need to do type validation, which is just going to go, okay, well, input validation, always the same pattern. Don't do a thing and then do the loop, just start with the loop, so which you start with like valid is false. Classic. And you initialize something, so you go in the loop, and then while not valid, colon, we are going to say that n is input enter a number, colon space, and then so I'm casting it here. If int of n is smaller or equal to 0, no. If it is larger than 0, strictly larger than 0, then valid becomes true. Now, come out of this, n is a string. This is very important because I'm going to need it as a string. This validates the input. Test this. You've done a bit of the thing, test it, right? Because you don't want to have bugs in here, like annoyingly preventing you from doing the bottom of the thing. So if I say -1, it keeps doing that. If I say 0, it doesn't accept it. If I say this, it breaks, right? But if I give it a positive number, it just ends, because that's it. But that means you can go into the rest of the code. Now, at this stage, n is a string. The reason n is a string is that I can do 4 digits in n. For all of the digits of n, I'm going to have I'm going to have some counter in there, right? I'm going to have some counter for increments, and some counter for decrements in between number, and I'm going to have the previous digit. And it starts as none, because I don't have a previous digit, right? So for the and d in n, if previous, as in I have a previous digit I can compare, meaning the first time is all going to completely skip. If int d, so d is a digit as a 1 as a character, right? When you cast it to an integer, it becomes a digit as a number, and if that is larger than the previous, it's larger or equal. That's the thing that is actually annoying, as we'll see, because it's possible for a number to both simultaneously be increasing and decreasing. The example they give, it's both increasing and decreasing, so it's not bouncy. It's not neither, it is both, so it's not like this arbitrary distinction. And same deal, we can't do an else because it might be equal. In that case, it increments. So, but yeah, just let's do the what happens in this conditional. We increment inc plus equal 0 plus equal 1, obviously, and then if d as an int is smaller, can I just not get all of the hints and previous colon, then it's dec that gets incremented. So we are going to make n minus list. Sorry, okay. We get number of digits. So if a four-digit number, we only make 3 comparisons because the first number doesn't have a previous digit, which means let's keep L as the length of n, because n is a string. Oh, not module, not found. N is a string, so that works, right? So we know that hopefully, or we can print L, comma inc, comma dec, and then let's test that. So first we kind of analyze the number, and then just like we've done the input validation, let's test this. Oof. So if I give it 1, 2, 3, 4, that I should have 3, 4. Okay, it's 4 long, and it's got 0 in each, which is a bit of a problem because what have I forgotten? I have forgotten to actually set the previous number to be the previous number. So once we've done all of the comparison to figure it out, then we set previous is equal to int d. So d, when it comes in, is a character, which is where I need to cast it, but previous is an int, and that's why I don't cast it here, because it's cast 1 over there. Saves you some cast to the extent you want your section B code to be perfectly optimized. Doesn't hurt to write the right thing in the first place. 1 for 4. I should have 3 increments and 4 long. Yeah, okay, cool. That has worked. I don't know if the rest will. So I have all of the information to decide. I'm just not sure how it's going to happen. So if inc it's equal L minus 1 for it is equal or inc or dec. So this tells me that I only have increases or only have decreases. Now it could be that could be both. So 1 1 1 1 will be things. So I'm just going to print not bouncy and probably exit help. I'm going to put an else here. Else. Now we know at this stage we know we are bouncy. We don't know whether it's perfectly bouncy. So it's going to be an elif, and the elif is inc equal dec. It's print. Perfectly b else print bouncy. Now they haven't given us a perfectly bouncy number to test, which is like super annoying because I don't really know which one should it be. So 1 2 3 not bouncy. Yeah, I still have my so the one they wanted to test with was here. Yeah. 9 8. Well, was it like 9 8 6 5 7? Notice they put a 5 in between 6 and 7 because of those 2 digits. 2 numbers are set in order. It is bouncy. 1 1. No need to run it again. This should say not bouncy. That's fine. Can I get a perfectly bouncy? That would be like 1 2 1. Perfectly bouncy, right? This goes once and then goes back then. So, oh yeah, what we did here, actually there wasn't, this is the second take, I didn't completely cold. I kind of like pooped the bed the first time it happened. I probably would have still got it on 20 minutes, but maybe not in exam condition. Input validation, because that's the first thing they ask you, right? And you know there's going to, I mean, I would have the mark scheme because it's 2025, but I got it of like script D where you have to watch an ad every 20 pages, so I'm not even contending with this. But first we need to do input validation, and you can do that, test it. Now, you know that the thing is all about the number of digits followed by that. So it's going to be kind of a previous comparing with the previous. So when you compare with the previous, you initialize the previous to none because there's no previous. And at the end of your loop, you make the previous what used to be, what is currently the current for the last time and will be the previous in the next loop. And then for each of those, you keep, you iterate over n, but n as a string, because that way your D should really be C, because it's a character. And when you cast that character, it becomes a number. If it's larger, you increment the incrementation. If it's smaller, you decrement the decrementation. Bearing in mind, because it's all equal, there's a larger equal, smaller unequal. If it's equal, both will increment, right? Now, I've just printed this for the sake of thing. Now, we know that a increasing number will have L length of the, if it's a 4-digit, they will have 3 increments, right? It's kind of in between digits. Or a decreasing number has got only decreasing changes, which again is L minus 1, then it's not bouncy. And so that takes care of 1 1 1 1, which, because that's both the case for them, because both inc is equal to dec is equal to, in that instance, 3. After we've sorted out the numbers we're not interested in, and then the case becomes, okay, perfectly bouncy or just bouncy. And what makes the perfection of the bounce is whether the numbers are equal. But you can't do this first. You can't do this like perfectly, then bouncy, then not bouncy, because there are some non-bouncy where that will be equal. So you kind of need to defend and rule out the increasing and decreasing number. All right, I've managed to get in 10 minutes. So please watch this space. I will do the end simulator because I really want to, just for my own sake. But I just need to find the time.